Hey guys, so in this video we are going to create the traffic. So on the last video we added the first car, and now we are going to add all the other four types of cars and make them move throughout the screen. So this is what we are going to have at the end. So now you can see that we have all five different types of cars, and all of them have different speeds, and we have different number of cars on each lane, and one of them start like three of them start from the right, the other one start from the left. So we are going to deal with all this. So the first thing that I did was adding all the other car types that I was missing. So basically I created new actor types. I added the sprite, the image, like the first one is just one image. Then I also edited the collision box of all the cars. So like we did with the first one, I changed the width and the height to 30 and did an offset of 1 on both axes. So we have this collision box. I changed the physics so the cars cannot be pushed and cannot rotate. So when the frog hits the car, it will not push the actor and not change the actor rotation. And what else? Oh, and I added the behavior, so the NPC movement. And now you see that on the NPC movement, we have the speed attribute as public, and now we can add different values to each one of the actors. So this is a really cool feature that we can use now with all our different cars. So you can see that each one of the cars, so car 2 has a speed of 224, -3, 448, and -5.6. And how do I got these values? Let me just show you. So this is just an overview of all the different data that I needed for each one of the lanes, and each type of the cars. So the first car to take 25 seconds to cross the screen. The second car takes 20 seconds, this one 15, 10 seconds, and 8 seconds. And this was the math that I used to get each one of the speeds. So I divided the width of the screen by the number. So 448 divided by 20, and then divided by 10, because the speed in Stencyl is at 10 pixels per second. The value that we use is 10 pixels per second. And so I got to each one of these values. And remember that positive values means that the actor will be moving from left to the right, and negative values mean that the actor is moving from right to the left. And so this was the first thing that I did, and then I needed to add the code to instantiate all the cars that we need. And initially, I don't know why I thought this, but actually I never thought about it, but I was convinced that when you start the game, all the cars would start outside of the screen and start moving. But it doesn't make sense, because if it was like that, would mean that the frog would be able to cross the screen, because all the cars will still be at the beginning. And actually what happens, at least from what the videos that I watched, when the game starts, most of the cars are already like in the middle of the screen. And this is a screenshot that I took from a video from the original game, and this is exactly as the game is when it starts. So you can see that most cars are already, I'm just deleting the frogs, you can see that most cars are already at some positions in the middle of the screen. So I checked the position of each one of the cars on each one of the lanes, and each lane has a specific number of cars. So the first lane has 3 different cars, the second and the third as well 3 cars, the fourth lane has only 1 car, and the last one has 2 cars, which are these bigger cars like trucks. So what I did was I checked the position of the first car, so in this case is 154, and I checked the distance between the first car and the second car, which in this case is 144. And so I added the code to instantiate for the first one, for example, instantiate 3 cars, and position the first one at 154, and the second one at 154 plus 144, and the third one at 154 plus 144 plus 144. So let me just show you how the code works, and it's not here, it's on the game manager. So the game manager is here. So you can see that you have a lot of code right now here on the when created. So I'm going to take this, and this is the code for the first car. So what I'm doing is that I'm creating a loop that's going to repeat 3 times because we have 3 cars, and I'm choosing the car number 1. And like I said, so the position of the car is always 154, which is the first one. The first one starts at 154, and then I'm adding 144 times the current loop count. And remember that the current loop count is index of the iteration that we are on. And when we are in a loop that repeats 3 times, the current loop count is going to be 0, 1, and 2. So this means that the first time that this loop runs, the first car is going to be at 154 plus 144 times 0, which is 154. The second car is going to be at 154 plus 144 times 1, so some value, 154 plus 144, and the third car is going to be at 154 plus 144 times 2, so it's going to be this one here. So we always start from the position of the first car and add 144 according to the number of the car. And this is the way that we get these 3 cars in the correct positions. And the Y position in this case is always for 16. And you can see that I have the Y position of each one of the lanes, and basically it's for 116 minus 32 to get, because it's the grid that we are using. And so this is for the first car, and I did basically the same for all the cars. So you can see the second car is the same. So I have another loop, repeats 3 times, car number 2, it starts on the Y position 384, and the only thing that changes is the initial position. So you can see that on the second lane, the first car starts here, and also the distance between the cars is a little bit different. So in this case, it's not 144, but 128. This is not like very exact value, so I just took the screenshot and just try to see the distance here in Figma, but that's what we got. And we have the third car, the same thing, also changes the initial position, and the distance is actually the same. Then we have the fourth car. Like I said, we only have 1 car in this case. So this car is going to start, actually I have 64, I'm going to 32. So this car is going to start outside of the screen. So you can see that we don't have the fourth car here. So basically what I did, I'm adding the initial position at minus 32, which means that it's going to start right here. So this is 0, and if the origin is at on the top left corner, and this is 32, so minus 32 is here, and the fourth card is going to start here, and so basically when the game starts, we are going to see the fourth card just coming into the screen. And it's only 1, so I don't have a loop. And the last one I have also a loop 3 times, and 3 times, not 3 times, it's a mistake. I have 2 times. We only have 2 trucks. Yeah, I just copied, so I forgot to change the name. So we only have two trucks, and they start at 154 as well. 154? No. Oh, I made some mistake here. I think I copied the code and forgot to change. So let me see. This is not gonna start at 154. It starts at, I don't know, 228, maybe? Yeah, 228. Something like that. And we have some distance between them, and we only have 2 trucks. So now it's probably correct. And so when the game starts, we create the frog and create all the cars. And since each car already has the NPC movement script, so they just start moving when the game starts. So let's see. Just gonna check if these changes that I made didn't break anything. And yeah, this is it. So we only have 2 trucks here. That was the main mistake. And yes, it's okay. So now, besides this, I also had to change the NPC movement behavior, because when we are resetting the car position, we need to take into account if the car is starting from the left or from the right. And I was actually correct on the last video when I started thinking about if I needed the initial position of the car, and I decided that I didn't need the initial position, but I actually need it. So I need to stop this habit of changing the code when I'm recording, because it never goes, it never is okay. So here, what I did was I added a new attribute. So I created a new attribute, once again, called initial x, not position. It's just the x position that we need. And what I'm doing is that, and now I'm going to just break this down. And what I'm doing is that when we create the car, what I'm doing is that if the speed is minus 0, which means that the car is going to be moving from the right to the left, then the initial position is going to be 448. And 448 is basically this position right here, so where the screen ends. But if the car, so if speed of minus than 0, set initial x to 448. Otherwise, else, if the speed is not greater than 0, meaning that it's 0 or greater than, then we set the initial position to minus 32, which is this one right here. And so, in this way, we have the initial x position for the cars, and taking into account if the car starts from the right or from the left. And I also had to add this, and this condition, it's because if you see in this case, most of the cars are already in a way inside the screen. So you can see that we have the 2 trucks here, we have the 3 cars, and even the third one is appearing here, and in this case as well. But on the second car type, you see that we have 3 cars in total, but the last one, it's outside of the screen. So what was happening was that since the car was starting outside of the screen, it wasn't running. So I'm assuming that probably the code didn't run because the car was already outside of the screen. And probably it wasn't able to set the initial position to some value, something like that. So I figured out that what I needed to do is that if the car, after we do all this set initial position, if the car is not on screen, so if the car is starting already outside of the screen, I just reset the position of the car back to the initial position. So in this case, this third car is going to be out of the screen, so it's going to enter in this condition, and the initial x, since the speed in this case, so it's moving left to right, the speed is greater than 0, so the initial position is minus 32. What I'm doing is, when the game starts, the third car is going to start here from the beginning. And I'm doing this with this condition. And so, all the rest we already had before. Oh, sorry. And this is it, I think. So, let me just show you guys again. And I think I didn't change anything else. So yes, we have the 3 cars, only 1, 2 trucks, and the other ones. All of them have different speeds and start on different positions, so they are not like in sync. Even if they had different speeds, they wouldn't be in sync, but they are starting on different positions. And this is it to create the traffic. And so on the next video, which I'm gonna record after this one, we are going to deal with squashing the frog when it hits a car. I can already show you guys. So for example, if the frog hits a car, it just plays the death animation and comes back to the beginning. So I'll see you on the next video. Thanks.